Rocks thunder down Big Sur's cliffs, severing California's Highway 1 once more. Along the wild coastline of Big Sur, the roar of collapsing rocks once again shattered the calm of the Pacific Ocean. Steep cliffs towering above the ocean suddenly gave way, sending millions of tons of earth and rock hurtling down. The legendary stretch of California State Route 1, known for decades as one of the most scenic roads in the world, once again suffered dramatic damage when sections of the cliffs supporting it collapsed without warning. This latest landslide is not an isolated incident. Geologists mapping California's coastal region have now discovered something far more alarming: more than 1,500 active landslides scattered along the escarpment, meaning the steep slope or long cliff of Big Sur. The new maps show that most of the slopes in the region are actually moving slowly, some only a few millimeters per year, but others have begun sliding more rapidly after extreme rainfall seasons. Scientists explain that the Big Sur coastline is formed from fragile sedimentary rock and ancient geological faults that have been unstable for a long time. For thousands of years, Pacific waves have relentlessly pounded the base of the cliff, slowly eroding the natural foundations that support the steep slope. When the overlying soil becomes saturated with rainwater, the entire slope can lose stability and collapse suddenly. Increased rainfall in recent years has exacerbated this situation. Heavy rains seep deep into the ground, increasing water pressure between layers of rock and clay. This pressure acts like a natural lubricant, allowing giant blocks of earth to slide down the slope with little warning. Under such conditions, even small vibrations or additional erosion can trigger major collapses. Climate change is also believed to play a significant role in accelerating this instability. Stronger storm patterns bring extreme rainfall to the California coast, while rising sea levels intensify the force of waves crashing against the base of the cliffs. The combination of these two factors creates a double whammy. The soil above becomes heavier with water, while the bottom of the cliff continues to be eroded by the sea. To understand this threat, engineers and scientists are now using much more sophisticated monitoring technology. Ground sensors are installed along various slopes to detect movements that are nearly invisible to the human eye. Meanwhile, high-resolution satellite imagery and LiDAR mapping allow researchers to measure changes in the land surface with a precision of a few centimeters. The collected data shows that several large slopes along Highway 1 are actually slowly moving, a process known as creeping landslides. Although the movement is slow, the increasing pressure can trigger sudden failure, causing portions of the cliff to collapse within seconds. This is why constant monitoring is so crucial. For transportation engineers, keeping California State Route 1 open is a major challenge. Each time a landslide occurs, construction teams must clear thousands of tons of rock, reinforce the slope with retaining walls, and sometimes even rebuild missing sections of roadway. But nature often moves faster than human efforts to repair it. The impact is immediate for local communities and tourists. This road is not only a vital transportation route, but also a global tourist icon that attracts millions of visitors each year. Road closures can cut off access for small communities along the coast and severely impact the tourism sector, the backbone of the region's economy. Now scientists warn that the future of this legendary coastal route may be even more uncertain. With more than 1,500 identified landslides and constantly shifting climate conditions, Big Sur is a stark example of how geological forces and environmental change can dramatically alter a landscape. Along these beautiful yet fragile cliffs, nature continues to rewrite the map, and humans can only try to understand and adapt to its forces.